Hi guys, welcome back to my channel. Myself Punit Kumar V, and I am going to explain about Z transform. Introduction to Z transform. A Z transform is a mathematical tool used for analyze discrete time system. It is an extension of Fourier transform for continuous time signals to discrete time signals. A Z transform provides way to represent discrete time signals and system in the frequency domain. Definition of Z transform. Z transform is a discrete time signals x to the power of n. It is defined as sum of all sample multiplied by the representative power of the complex variable z. It is denoted as xz summation of xn, where n range from minus infinity to infinity. Range of convergence. The R was a set of complex values of z for which is Z transform converges. It determines the convergence and divergence of the Z transform. The ROC can be inside or outside a circular region in the complex plane centered at the origin. Properties of the Z transform linearly. The Z transform is linear, meaning that it satisfies the superposition property. If x1 z and x2 z are the Z transform of two signals x1 and x2, here is an example of simplification of Z transform. Properties of Z transform. Shifting the time domain corresponding to multiple powers of z to z domain. If xn has z transform xn, then xn n minus k has the z transform of x to the power of minus k. Properties of z transform. The reverse in the time domain correspond to complex conjunction in the z domain. If xn is as a z transform xn, then x to the minus 1 as a z transform of x. Properties of z transform. Convolution in the time domain corresponding to multiple z domain. If x1 n and x to the power of n as the z transform of x1z and the x2z respectively, then the convolution xn is equal to x1n, x2n as a z transform x1z. Here are the functions and time functions and Fourier transform of z transform: linearly, time shifting, time scaling, time transform, duality, frequency with convolution, differentiation, and integration. Inverse Z transform. The inverse Z transform is used to recover the original discrete time signals from its Z transform. It is denoted as xn is equal to 1 by 2 pi j mod of x z, where the integration is performed along a closed path of ROC. Application of Z transform. Z transform is usually widely used in digital signals processing, control system, and communication system. It allows the analysis and design discrete time system in the frequency domain. Z transform technique are used for digital filter design, system stability analysis, and signal processing algorithms. Conclusion: a Z transform is a powerful tool for analyzing and designing discrete time systems. It provides a way to represent and manipulate discrete time signals and systems in the frequency domain. Understanding the properties and applications of the Z transform is essential for digital signal processing and control system engineering. Examples: consider generation of new discrete time signal from f of k to g via g of k. G of k is equal to f of k minus 1. Recall linear and shifting. G of z is equal to 1 minus z inverse f of z. Z transform of cos kt it can be written as e power